So welcome to we have 5.5 solving exponential and logarithmic equations. This will be the last episode of the series. No, this won't be the last episode of the series. This will be the last episode of solving exponential and logarithmic equations. Now we have 100 to the x minus 2 equals 10 to the 3x. We know that 100 is 10 squared, and we want to make the bases the same because if we make the bases the same, then our exponents will be the same. So once we make the bases the same, we multiply the two bases. We multiply the two exponents because a power of a power is the product of powers. 10 to the 2x minus 4 equals 10 to the 3x. 2x minus 4 equals 3x. And then if you do the algebra, negative 4 equals x. Now in this case where you have 8 equals 5 to the x, you want to get rid of the 5. You really want to get rid of the 5. So in order for you to get rid of the 5, you can just do log base 5. Because remember, in the previous chapter, log base 5 of 5, or log base anything of anything is equal to 1. And if we have x on top, we can move the x here. We'll get log x times log base 5 of 5, which is just going to be x times 1, which is x, right there. So log base 5 of 5 is equal to 1. And you take log base 5 of 8, you will get x is equal to 1.29, just like this, right? So we're going to work through some practice problems. First of all, 2 to the x equals 8 to the x minus 6. So let's work it out. 2 to the x, let's put that up. 2 to the x equals 8 to the x minus 6. Now 8 is 8 can be represented as a power of 2. So 2 to the 3, 2 to the third power minus 8 to the 8x minus 6. And we can put x equals 3 to the x times x minus 6, which is 3x minus 18, right? And then we can subtract 3x. I'm going to write it down here. 3x minus 18 equals x. So we can subtract x on both sides. No, we can subtract 3x on both sides. So then now we have negative 2x, and that's equal to negative 18. So x is equal to 9. There you go. So the first problem, x is equal to 9. Next, 10 to the 3x minus 4 equals 1/10 of x 1/10 of x minus 6. So 10 to the power of 3x minus 4 equals 1/10 to the x minus 6. In order for us to turn this 1/10 into a 10, we have to make it negative, because if it's negative, it will flip. We will be able to flip the fraction, just like how we did on our used to do on our exponentials. We flipped our x to the bottom, and we flipped our y to the top if it's negative. So the same thing here. We have 10 to the 3x minus 4 is equal to, we flip this, it's 10 over 1, which is the same as 10, and then we have negative x minus 6. Now we can put them equal to each other. 3x minus 4 is equal to negative x plus 6, because negative times a negative. Add 4 on both sides. Add x on both sides. Cross that off, cross that off. We have 4x equals 10. So x is equal to 5 halves. So in this question, x is equal to 5 halves. Okay, I'll erase everything. If you want to pause the video now, you can pause the video for the work. I'll start to erase. Our next question is 8 to the 3x equals 32 to the 2x minus 5. So we have 8 to the 3x. These 32 cannot give us a base of 8. like a base where 8, an exponent where 8 is the base. Unless if you do some really complicated stuff with the fractional exponents, with the rational exponents, you will not be able to achieve 8. So we can make it super simple by just putting them both in bases of 2, because that's 2 to the third power, that's 2 to the fifth power. So we have 2 to the third power to the 3x equals 2 to the fifth power to the 2x minus 5, which will give you 2 to the 9x equals 2 to the 10x minus 25, right? And then now we have negative x is equal to negative 25, so x is equal to 25. There you go. That's it. X is equal to 25 in this question, which seems like a really big number, but it's true. X is equal to 25. Okay, I'll erase this. Now, we don't have an exponent on the other side anymore. So, in order to find out, we have to take the log base whatever of the number that has the variable as its exponent. So we have 7 equals e to the 2x. Our number is e, so we have to take log base e, which is also known as natural log. So we have to take the natural log of e and the natural log of 7. Right, now we have 2x is equal to ln of 7. Divide by 2 on both sides. We have x is equal to natural log 7 over 2, which is also equal, oh god, I can't write the 2, also equal to 0.973. 0.973. So x is equal to 0.973, or roughly equal to, right? Same thing here, we got 8 to the x equals 88, so you can take the log base 8 this time of both sides. Now we get x is equal to log base 8. Oh god, I can't write 8 of 88. And what is log base 8 of 88? Log base 8 of 88 is more than 2. It's 2.153. So 2.153. That is our answer. So this is solving a logarithmic equation. So I have already established the identity that a to the log base a of any number is equal to that number, because log base a of that number to that number is also equal to that number. So the opposite holds true, right? So we have certain ways to alleviate that. Here are some examples if you want to look them over, but I'm going to go on to the solve. I'm going to go on to the solve section. Okay, so we have 3x plus 5 is equal to 4x minus 7. You can just, according to this, we can just take it to the power of the base, and ln is log base e, so we can just take it to the e's power, which will give us 3x plus 5 is equal to 4x plus 7, 4x minus 7. Excuse me. Right? And then we can just subtract 3x on both sides and add 7 in order to get x is 12. X is equal to 12. So we have to plug into the equation first, right? 3 times 12 plus 5 is 41, and 4 times 12 minus 7 is 41. So 41 is equal to 41. Correct. Right, log base 2 of 3x plus log base 2 of x is equal to 9. So in this function, we actually have to factor. We actually have to we actually have to use the product rule that we learned last time. So when they're added together, they're actually multiplied. So multiplied by x will give us log base 2 of 3x squared, and that's equal to 9. So we can just put both sides to the power of 2, we get 3x squared is equal to 3x squared is equal to 81. Subtract 81 on both sides. 3x squared is equal to minus 81 0. Then we can do our 3x squared minus 27 is 0, and then we can factor it out to a difference of squares. It's not a perfect square, but we can still factor it out to this difference of squares, which will give us x is equal to negative square root of 27 and square root of 27. Obviously, if we put in our okay, I did this wrong, and we will take 2 to both powers, but we'll have 3x squared is equal to, now 2 to the 9 power is a huge number, so I'll change it. No, I won't change it. It's going to say 2 to the 9 power, and that's 512, right? And if we divide by 3 on both sides, we'll get x squared is equal to 512 over 3. And this is a really not so neat of a number, so we take the square root of both sides. Now we have x is equal to plus or minus square root of 512 over 3. But since the minus, whenever you put it in the function, it doesn't work. So our plus is the only one that's left. So x is equal to 512 over 3. Square root of 512 over 3. Now solve for y in terms of x. Log 4 of y minus log 4 of x is equal to 4. We want the y, so we can just, using the quotient rule, we can combine these two together. Now we have y minus x, log base 4 of y over x is equal to 4. We can take the fourth power both sides. We will have y over x is equal to 256. And then multiply by x on both sides. We'll have y is equal to 256x. That's it. That's a really steep linear equation. And we also have to define it as x cannot be lower than 0, lower than or equal to 0, right? That's if we had that function. So our next page is solving logarithmic inequalities, right? We can just, it's really simple. We can just do the same thing that we've been doing all along. Take the third power of this. We'll have x. It cannot is smaller than 3 to the 8th power, which is a really big number, 6,561. But in this case, the log base 3, the log function log functions cannot go, log function is defined for x is higher than 0. So x cannot be lower than 0. So this is our domain, is 0 to 6,561. Same thing as this. We have e, we'll put e to both sides. We'll have x is higher than or equal to 3x minus 5. And then we will subtract 3x on both sides. We will have negative 2x is higher than or equal to negative 5. So x is lower than or equal to 5 over 2. And we have to switch signs whenever we're multiplying or dividing by a negative, right? And as I've said before, the log is only defined for x is higher than 0. So we've got to put this as higher than 0 as well. Here are some problems on why this on this solving equation. So we have our why is this wrong, right? First of all, log base 3 of 5x minus 1, and this is actually a mistake that I made like 10 minutes ago. Log base 3 of 5x minus 1 is equal to 4. If you take each side to the third power, for example, take each side to the third power, you're taking each side to the third power. You're not actually putting it to that power. Because if you do that by square roots, now if this were to be this, it would be absolutely correct. You would take the third power, right? 4 to the third power. But no, this is not a square root, so you had to write 3 over 4, right? This function is actually really subtle. The mistake's really subtle, and I've already told you guys that the log functions only define for x is higher than 0. So he did all of this correct, right? He combined the function. He did 4 to the third power, like a normal person, not like her. X plus 12 times x is 64. X times, yeah, he factored it correctly, but this is not acceptable, because if you put negative 16 plus 12, you'll get negative 4. And log base 4 of negative 4 is not defined, is undefined, right? You can't do it. So the correct answer is just x equals 4, right? Anyways, modeling with mathematics, the apparent magnitude of a star's measure of the brightness of a star as it appears to observers on Earth. The apparent magnitude m of the dimmest star that can be seen with a telescope is m equals 5 log d plus 2, where d is the diameter of the telescope's objective lens. Thus, the diameter of a scope's objective lens with a lens of a telescope that can reveal stars with a magnitude of 12. Right? So we can just, this seems like a big complicated problem. It's not. We just put 12 for the m. 12 equals 5 log d plus 2. Subtract 2, 10 equals 5 log d. Right? Divide by 5, 2 equals log d. Put both sides to the 10th power. D is equal to 100. So 100 millimeters is the size of the telescope's objective lens. Simple. Next, rewriting formula. A biologist can estimate the age of an African elephant by measuring the length of its footprint and using this equation. In the footprint, well, L is the length and A is the age. So rewrite solving for A. So we're going to solve for A. We're going to do L equals 45 minus 25.7 e to the negative 0.09a, right? We're going to subtract 45 on both sides, right? Subtract 45. Now we have L is minus 45 equals negative 25.7 e to negative 0.09a. This is going to look really messy. Divide by negative 25.7, right? Now we have L minus 45 over negative 25.7 is equal to e to the negative 0.09a, right? E, in order to get rid of e, we take the natural log. So we have our natural log of this whole thing. Natural log of L minus 45, minus 45 over negative 25.7 is equal to negative 0.09a, and then you just divide by negative 0.09, and this is our function right here. So a is equal to the natural log of 1 minus 45, of L minus 45, just gonna write L over 25.7 all over negative 0.09. So I'm not even sure if that fits the, yes it does, okay. So we want to find the ages of the elephants whose footprints are shown. I'm just going to get rid of these three because the video is already too long. So let's put 36 in there. Now we have natural log of 36 minus 45 over negative 25.7 over negative 0.09. So 36 minus 45 is negative 9, right? And then negative 9 over negative 25.7 is 0.35, right? And then the natural log of 0.35 is negative 1.0. So let's write that down, negative 1.0. We'll write it down to 3 decimal places, negative 1.05. Oh, and then divide that by negative 0.09, which will give us 11.66. So roughly 11.66 years old. 11.66 years old for this guy, right? And if you keep, the lower it is, obviously, the lower the years old, the lower the amount of years old it's going to be. Actually, yeah. So the lower it is, the lower amount of years it's going to be old. So that's it for today. And if you liked it, press like button. If you want more videos, then just tune in for the next few videos. I'm gonna be uploading a lot this summer. And that's gonna be it. So take care and see you next.